Good day to you all. In this video we're going to talk about Pluto. It used to be the ninth planet from the Sun, but in 2006 the astronomical community decided to make it into a different category because its size wasn't enough, and there were three categories that basically were making a planet in the astronomical community. The first one is that the planet should be a sphere. That Pluto is a sphere, a tiny one, but it's still a sphere, which is a round object. It's supposed to orbit the Sun, not another planet. And the third one is it's supposed to clear out any debris in its orbit, which in this case Pluto fails in this category. Why? Because Pluto is basically the first member, or at least the first member we know about, from the Kuiper belt. The ring of objects around the solar system, around the Sun, that has plenty of icy bodies and other dwarf planets as well besides Pluto. Now we know about 6 to 7 dwarf planets, but there could be a lot more of them in the other reaches of the solar system. Now Pluto is about 1/3 the size of the Moon, and yet only 1/6 of its mass. It is made mostly of ice and rock, and yet it has young features or at least youthful features like youth in terms of looking pretty young without any craters on them than any others. Now, Pluto has a very eccentric orbit around the Sun that takes about over 248 years to orbit the Sun once. However, its orbit takes it from 4.5 to 7.3 billion kilometers. And actually, fun fact, his closest approach takes it slightly closer than Neptune to the Sun. Neptune is to the Sun. That means that basically it goes closer and they should collide potentially, but because they have orbital resonance that basically allow them not to collide, which is an interesting fact. Now, Pluto has 5 moons. One of them is Charon, which is basically the biggest moon it has, about half its diameter, and they are basically orbiting so close that they are basically like a binary planet system, or a binary body system, if you will. However, Charon has something that basically Pluto we already found, but I will explain it later. Now, Pluto, basically, let's talk about him right now because it's the main focus of this video. Now, Pluto has been visited basically once by the New Horizons space probe in a flyby. That flyby allowed us to basically see many of the features we saw on Pluto, and we got a detailed picture of it, a detailed analysis of its composition. Now, we also noticed that Pluto has a temporary atmosphere. Now that means that in its orbit, when it gets closer to the Sun, in its super summer phase, if you will, it basically heats up enough to allow for the existence of a very thin methane kind of atmosphere. Now, the methane in the atmosphere allows the atmosphere itself to also create wind. Now, this is a very weak wind, but it's enough to create what we found as dunes on its surface made of ice particles. Now, compared to the dunes on Earth, which are basically made from sand particles of silicate, basically silicon, in this case, this is literally made of ice. But you could see them, and they are created because of the wind. It's slowly moving them around on the surface of Pluto. However, when it gets further from the Sun, in its furthest point in its orbit, the atmosphere freezes over and it loses it basically. So it has a temporary atmosphere, unlike ours, which is a constant one, let's say. But again, it's a very thin atmosphere, and it looks like a blue line if you look in some pictures. Now, of course, he has other tiny moons that are orbiting very fast around it besides its biggest moon, and basically has the biggest number of moons from all the dwarf planets in the solar system we found so far. Now, Pluto basically orbits in an angle of over 120 degrees or so, or at least 120 degrees. So it orbits very tilted, to the point where we think that in the past, a very big comet most likely, hit it in an angle and created a crater which was filled with water that was under its surface. Those water freezes over, and the weight moved Pluto around towards its current position. But it's not just that. The moon Charon basically moves around and also pulled on Pluto. So together with the weight, the pull, and all the other factors, it basically moved down towards its 120 degrees tilt. Now, one of the most interesting features on Pluto is actually Pluto's heart, which is the crater that was created by that impact we just talked about. So now I'm gonna also talk a little bit about Pluto and shows some pictures so you can figure out and see what else is done about him. Now the first picture I'm gonna show basically just shows Pluto with the data from the New Horizons spacecraft, which is basically a very interesting thing. Now if you see, you have Pluto's heart right about here, and you can see it has a lot of white surface but also some darker surface area like here. And you can also see, of course, some craters, but this is basically a very detailed picture of Pluto, of course. Now, discovery of the Pluto in the first part, this is how it was discovered, basically. And this is the one who discovered it. And this shows its orbit. As you can see, it moves, through the years it was discovered, basically moves here, and in this section, it goes closer than Neptune is towards the Sun. But then it goes right out back. It's a very elliptical orbit. Now here it's also very tilted compared to the other planets and the other bodies in the solar system, if you will. Now this is a 3D animation, rotation move of Pluto based on the New Horizon. This is some of the features, ice cells. Now what's interesting about the ice cells, and I'm gonna explain about them, those ice cells are heating up, which means something is bubbling down the surface. So you can see that basically it's a very young feature in some way. It looks very young because it's changing. The ice underneath is heating up, and you can see those areas that looks like cells, and those cells are basically just heating up with some internal heat source. Now, interesting fact about that is that Pluto basically is still active, but not in the way you might think. Unlike the Earth, which has magma underneath in the mantle, in this case, Pluto has water underneath, most likely, and ice. Now, apparently ice can heat up by itself in some interesting chemical process that I don't know for sure, to be honest, how to explain, but apparently ice can heat it up, can heat itself up in some way. And that basically allows for the planet, in this case Pluto, Dwarf planet Pluto, to be active more than we thought about because of this tiny little planet. So it's an interesting thing if you think about it. So those cells are basically from maybe a lake of water, salty water underneath this area, which is very cool. And this is not, once again, a picture that is even more detailed, but not by enough. This shows some of the areas that are impact craters and basins, and Pluto and its moon Charon, of course. As you can see, this is the moon, and this is Pluto itself. You can see there is a bunch of craters, every one of those basins, craters, you name it. This shows basically this explains a bunch of chaotic material, plateau, and give you an example of the areas on Pluto basically and around its heart, which is very cool. This shows regions where water ice has been detected. In these areas, the blue ones, there was water ice in them detected, which is very nice. And this shows the layout that we think that Pluto has. Model that basically shows what we think about. In this case, it has a silicate rock core, which is understandable. It has water ice crust, liquid water ocean underneath that crust, which basically heats it up in some way. And that's very interesting thing also. Size comparison, of course, Pluto is very tiny compared to the moon and the Earth, but it's still a round body. And this is the most interesting thing. We talked about the atmosphere, and here it is. In its super summer phase, where it's the closest when he is in this closest approach to the sun, you can see it has an atmosphere. Temporary one, but still visible if you do it. This shows the orbit of the moon, of Pluto, the biggest moon, and Pluto itself. As you can see, Pluto is moving in a small orbit, while this one moves in a bigger orbit. They orbit the common central mass. This is the other moons. As you can see, they are very tiny rocks. And this shows the area of Pluto is, which is basically the Kuiper belt. and so on. This is how Pluto looked like at first. This is how it was pictured by the Hubble Space Telescope. Not a lot, but it was. And here once again a picture, panoramic one, that shows the atmosphere and the surface of Pluto. Very interesting. You can see some hills, some cryovolcanoes. Very interesting thing. And this basically kind of shows the end of it. Now, once again, we can tell that Pluto has a very interesting cryovolcanic activity, like we said. It spews out water that, when it in certain ways, can be liquid for a while and create some cavities and canyons and rivers that eventually they freeze over when the planet goes furthest away from the sun. Now, those water are much saltier, most likely, than the water on Earth, which means they can be liquid for a longer period than regular water, if you will. So overall, Pluto also has something that we didn't think we would find on this small dwarf planet: organic compounds, which means organic compounds that are necessary for life as we know it. Now, Pluto has them, but his moon also has them. But why, you may ask? It's pretty easy. Some material from Pluto was ejected by an impact a long time ago, and this material basically flew into his biggest moon and covered this area with those organic compounds, which his moon didn't have, but now it has a patch of them, an area, if you will. And Pluto, despite even though we know a lot about them, we discovered a lot about them by the New Horizons spacecraft, we still don't know a lot about how the processes inside of it work. But we do use it to model some other dwarf planets we found, like Makemake, Haumea, a bunch of other dwarfs. Sedna, which is also a dwarf planet covered in organic compounds, together with others. Ceres also. So we still don't know a lot about this body, but we do know enough about them to say, well, it's a very interesting body indeed. So this was a little bit about Pluto, about moons a little bit, mostly about Pluto, which is a favorite dwarf planet of mine, and used to be a planet until 2006. So hopefully you enjoyed this video, and I will talk to you again next time. See ya.